Well, hello and thank you. My name is Vince Westin. I'm a technical evangelist for Dell Technologies, working on PowerMax and other storage products. So I haven't been around quite as long as John. John's been around more than 30 years. I've only been around 25 years. But we're glad to be a part of this tag team today to help talk through what's going on with PowerMax. John kind of talked about the overview of mission critical apps and how we're affecting things. I'm now going to take that and drill down into the highlights of some of the technologies. Right? I mean, there's not enough time to go really deep in 20 minutes, but we can selectively go deep in a few technologies. So that's what we'll do here. Specifically, we're going to talk through the hardware. So this is the one slide on hardware and what we're doing. PowerMax comes in two versions, the 2000 and the 8000. The 2000 being 2 to 4 controllers. So it still scales, but it just scales smaller. The 8000 going from 2 to 16 controllers. So you can get up to 8 bricks crossing 2 racks, multi-petabyte systems with millions of IOPS. And there was a question before about bandwidth. On each of these, you're talking about realistic bandwidth in the tens of gigabytes per second per brick, right? So a PowerMax 2000 doing 20, 30 gigs a second, no big deal. PowerMax 8000, we have specs as high as 300 gigabytes a second. Realistic workloads doing 80, 100, 150 gigabytes a second on a single array is very possible. And part of what John was talking about in the data reduction side was you can turn on data reduction and still maintain performance. And so we'll talk through some of how all these pieces work. But we've got the scale up on the array. We've got scale of ports. We've got scale of connectivity in various ways for not only front end, but also for replication. And we've got all the base software you'd expect. So, the snapshots and the data reduction, the ability to do non-disruptive data mobility into the array, the ability to get information on your copy data management, lots of other stuff. And then we also have a pro package that adds things like remote replication, data at rest encryption, the ability to turn on NAS in the box, PowerPath licenses, and a bunch more. So just some great ways to use the array, to try and make it really simple. Just buy one package pro and you're done, and you get to do anything you want with the box. In terms of the focus, PowerMax is designed to drive down response times. So John kind of talked about some of the things we're doing around customer focus and intelligent I/O. So I'll just kind of reiterate what he said about the latency, but get in a little more detail. And so we're using machine learning to decide where to place things, because we find that more than 80% of the I/O happens on less than 20% of the data. Our goal is to avoid data reduction on the hottest 20% of the data so that we avoid decompress on that hottest 80% of your I/Os, right? So as long as there's free space in the box, if you're running it 50, 60, 70% full, we will not bother to reduce the hottest 20% of your data. And lo and behold, we'll save you 50 microseconds or so on every read. And you just get better response time. And then as you fill the box up, we'll compress it all, right? So we have the ability to be intelligent about where we do data reduction and how we apply it and how we benefit you from that. And we also have the ability to drive down that latency. Now, 50 microseconds doesn't sound like a lot until you think about the fact that the average response time you're talking about is less than 500 microseconds. So this is more than 10% savings on your average random read by not having to decompress that data. So it really does make a difference to our customers in what they see. And then, of course, we're all NVMe on the back end. It's all NVMe over PCIe all the way through, from the drives through the memory and out through the front end if you do want to turn on front end NVMe connections. And then we also have the ability to do storage class memory. And this isn't storage class memory as a cache or storage class memory as a buffer for writes or something. It's storage class memory as storage to, again, lower latency for that hottest data. And we will automatically place the most active data on the storage class memory so you get the most value out of it. So adding 3 or 5% storage class memory to a box may impact the response time on 30 to 50% of your hottest random IOs. And we do all that automatically. There's nothing for you to touch or do with it. It just happens. It's how the box works. In terms of the architecture, John talked about scale out. So if you start with one brick with 2 directors, you've obviously only got the cache going between the two. So we use a memory interconnect there, and away we go. And then when you start doing multi-brick things, we have this wonderful fabric. And so the fabric allows us to just scale out. And so all of the directors talk in this non-uniform memory access way so that you get parallel access to the same data across the entire box. The metadata is shared, the user data is shared, writes are mirrored across directors. When you've got more than one brick, they're mirrored across bricks. We do everything we can to make sure that you get the best performance and availability. And then if anything happens to one director, everything else just keeps running and we replace that director and come right back online and everything's happy. And
so,
you're not taking...
So Vince, maybe you
Yes,
could
sir.
describe the difference between controller, brick, and director.
Okay, so controllers and directors we use interchangeably, right? A controller or a director is the card that has the CPUs and memory and all those things, the front end attached, the connections to drives and all that. A brick is a piece of sheet metal that holds two of the controllers or directors. So we sell the things.
So in this
pairs.
chart, for instance, that one of these things to the left or to the right would be considered a controller, and then two of these would be considered a brick?
Right. So on the left-hand side, you see the first card with some green and blue and A and B on the bottom, right? That's one director.
Right.
And then right next to it is the second one, and then you can kind of see the sheet metal surrounding it. And when I say it's sheet metal, it's really strong isolation. One of the things we figured out early on was even sharing things like power was a bad idea. So there's redundant power to each of the two directors, and they don't share their power supplies at all. So there's actually 4 power supplies in one brick. So you get dual power to each director that's fully redundant. So you can lose 3 out of 4 power supplies and you've still got a director line, right? Even if you only had a 1 brick system. So lots of redundancy within that sheet metal.
All right,
that help?
Thanks. Yep.
Good. Online code updates. One of the things we've done for a long time that really makes a difference, John's talking about the always on environment. Always on doesn't mean always on except when you're loading code. It doesn't mean always on except other things. It means always on, right? You power the array up when you bring it in, you power it off when you take it out, and in between, it stays available. And so we've got the ability to do the online code load. It's less than 6 seconds. You basically load the code in the box. We don't drop light on the ports, so the fabric doesn't see log out, log in. You don't get state change notifications, so the servers don't go doing rediscovery. Right? We stay on the fabric throughout the entire thing. So this is invisible to the servers. There's no path failover, failback. There's no trespass of LUN ownership. Right? It's all just magic. And then if you go forward and you do this code upgrade and you say, I didn't check something or I didn't upgrade something, I really want to go backwards, you can do the same process, go back to that old code online, right? Same 6-second process, same never drops light, it all just works. And of course, the first thing that the change control guys ask every time you say you're going to do a code upgrade is, what's your backup process, right? So being able to say, and we can downgrade, makes it easy. We have demos for you if you want. Don't have customers doing that in production much. I have one customer who did it once to prove to a change control guy he could. I'm not aware of anybody else who's done it in production, but we do it in the lab all the time for customers who want to see it. So whatever you need, we're here to be able to show you this. It's something that's been vital to the product for the last 25 years, as the history of Symmetrix VMAX PowerMax. Just as an example, we had a customer who did an online code load, and they're running along, and they're monitoring all their applications, and they were seeing sub-millisecond response time things. And then when they did the code load, their response time showed a little blip, and away they went. Now, again, the code load itself actually takes more like 6 seconds, but the application wasn't doing enough IOs in just the right time frame to see things. It didn't notice it. To them, it was like, yeah, okay, our response time went up just a hair, and we're done. Right? So it was really, this is what customers tend to see. They're like, well, you can do the code load anytime. And we say, well, we're done, right? It's something, again, we've been doing this for decades. It's not a big deal, but it is fairly unique. And the downgrades are definitely unique. We've got data at rest encryption, not a huge deal in terms of everybody should have this these days. We are FIPS validated, and we do have a separate key for every drive. So when a drive gets replaced, we can remove the drive, shred the key, put in the new drive, generate the new key. There's nothing else to do. Right? There's no user management of keys. There's no access to keys. You can have an external key manager if you want, but there's nothing for you to manage. You just turn on data at rest encryption when you buy the box, and it's done. And this is something that almost all of our customers are using now, and something that's considered table stakes for most high-end products. We've talked about some differences in the past between VMax and PowerMax. So as we moved from the all-flash product to PowerMax, we added a new data reduction card that does deduplication. So we have this really nice example of a customer who's doing VDI. Now, this is an unusual example, but it has them to show off the value of dedupe, right? So they're running VDI. They've got a whole bunch of data that happens to dedupe well, but they've got a bunch of binaries and other things that don't compress very well. So on their old PowerMax, on their old VMax all-flash 950, they were getting about 1.5 to 1 in terms of data reduction. And they moved that same workload over to a new PowerMax 8000, and now they're getting 6 to 1, right? So it made a big difference because there happened to be a bunch of duplicate data and we could dedupe the daylights out of it. That's not saying that average customers are going to do this, but that is saying that if you have a workload that deduplicates well, we will definitely get that and we support it. On average, we're seeing like a 30% savings from data deduplication in PowerMax, but some go a whole lot higher. Some will go lower. I mean, a big database doesn't tend to dedupe much because there just aren't many records that match up. So now we'll go into some of the advanced tools of local and remote replication. So snaps are at scale. John mentioned some of that earlier, but just to be clear, we can do 1,024 snaps on every device in the box. And so that's 64 million snaps because 64,000 devices. That sounds like a bit of a silly number, but we'll talk through kind of why that's important and some things in the future. We also have the ability to secure snaps. So on an individual set of snapshots, you can say, hey, I need to make sure that nobody accidentally or maliciously takes these away. I'm counting on them in my infrastructure, make those secure. Yes, it makes them harder for me to delete. I've got to call people and do two-factor authentication with humans and do all this other stuff to get anything done with that. But it makes sure that the bad guys can't come in and just delete thing and I don't do anything accidental, right? So great, we've got that going on. How do we make that easy? So John talked about all this being simple. You can't manage it. If it's not simple, you won't use it, and there's no point in having it. So we have service levels available for the snapshot. So rather than you setting up schedules and managing all of that, you turn on a snapshot policy. So I've got a policy that says, I want to run 10-minute snaps for 2 days, and I want to keep those secure, right? So you can't delete them. Those are my protection against malware, whether it's ransomware or whatever. I want to avoid problems in my data. I want to have an easy way to recover rapidly. So I'm going to do 10-minute snaps. I'm going to keep them around for 2 days. Yeah, it's about 288 copies of data, but whatever, I'm good with that. Right? And then I want a retention policy of 2 weeks for, I want to be able to go back and look at the database and figure out what happened because somebody comes 3 or 4 days later and says, hey, something went wrong. I want to be able to quickly just take a snap, mount it to a server, go look at things. Oh, yeah, something changed, extract that data, import it back into production. The number of databases we see actually getting restored from a copy after about 48 hours is right near zero. Right? But the need to go restore pieces of data is still pretty high. And almost all recovery of data is done within 14 days. So having this policy that says, yeah, keep 4 times a day for 14 days, that's great. Now I've got all those snaps. I can grab all of that stuff and I never have to go outside the array to get it. Now, obviously, you still need backups. Right? Doesn't help you if you dump water on the array or something else happens, catastrophically in the environment to take the box out. But most of your recoveries are going to be my array is fine, something happened to my data, and between these two, that'll cover it. Now, the 14-day ones we don't tend to run as secure just because if you start running out of space, if you make some big changes, if there's a whole lot of snap deltas being used in the frame, you want an easy way to just drop some of the older ones to free up space without having to do all the overhead of being able to release secure snaps. And the whole point of secure snaps is you should leave them there, right? It isn't something you should be breaking on a regular basis. Oh, I need more space. Let's just go drop some secure snaps. If you get in the habit of going out and finding ways to unsecure your secure snaps, then they're not secure anymore, right? You're not using them as truly secure product. So you want to be able to differentiate. You have both in the array at the same time. And then John mentioned the snaps to the cloud. So I'm set up weekly snaps. I'll keep them out there for 2 years. That can be really useful when you get these questions for legal discovery. Hey, I believe that 18 months ago when I was applying for this loan, that the data you had on me said Y and you said X and whatever, right? Okay, great. I've got a copy of the data that's 18 months old. I can grab that from the cloud. I can, as John talked about, mount it up to a server and go explore it. And here's the export. Here's the data we had on you at the time. It matches exactly what we told you. Here's the lawyers go away.
Hey, Vince.
Right? Yes.
So normal snapshots are like differential kinds of things. The snapshots to the cloud, are they fully hydrated? I don't know what the right term is, but I mean,
So they're virtual fulls. They are still differential.
but they are
So
virtual fulls based on what's actually in the cloud, not what's on the array.
right. So each thing in the cloud is entirely independent. So the first snapshot to the cloud is 100% copy of the data, and everything after that is deltas. And then over time, you can release the original. Right, when you get to the expiration of the first one, you expire all the parts of the first one that aren't needed by the second one, and so on.
I got you. All right.
Thanks. So you basically wind up with a full copy of the data in the cloud on the first snap, and then you do deltas from there. And it makes it really easy to just, again, if the primary array got wiped completely, you could even theoretically restore from that copy back. Your restore from your local backups would be a whole lot faster, but you'd have a cloud-based copy that you could go do something in if you needed.
All right. Got it. Thanks.
Yep. And then you can combine these policies. So on a storage group level, I can say, yeah, this storage group is really important. I'm going to apply all these. Or you may have others that, yeah, I don't care that much. I'm just going to give it the, 4 times a day for 2 weeks because it's test dev and I don't really care, but I don't want the test dev guys to come and say, hey, I just wiped out 7 weeks worth of work. Ready, I can give you everything but the last 6 hours. Let's go. Right. You apply different policies to different storage groups. And again, this all just gets automated. It happens in the background, nothing for you to work on. So why might you do that for like an Oracle database? So this gives you the ability to recover from logical, physical, operational, malware, whatever kinds of issues, right? It does the entire database. And because of the tools that Oracle has, you can actually roll forward after a storage-based copy, or you can just go mount up the copy somewhere again and do selective recovery. Yeah, we're going to look at these transactions and recover that part of the database back, right? So that's a great thing to have. So we'll talk about the kind of snaps we just talked about making in the previous slide, right? So every 10 minutes gives me 288 point-in-time images, really great granularity to recover from, malware, or somebody copies over a data file, somebody absolutely drops the wrong things, somebody did a bulk import with direct on, so there's no logging, but it's put garbage all through the database, right? Whatever I need to fix, I've got, 10-minute snaps going back for 2 days. So I have to do a restore. Odds are it's right there in the database, and it's a virtually instant restore because once you start a snap restore, you can start using it while the pointers get straightened out in the background, right? That's a great thing to have, especially for things like malware recovery where the bad guys are trying to do bad things and you just kind of smack at them and say, yeah, I don't think so. And then we've got the snaps, again, every 6 hours you keep for a couple of weeks that you might use for going and interrogating, hey, what was that like, 4, 5, 6 days ago? And then the snaps in the cloud for historical and records and legal holds and all the rest. So you can easily apply that. You can get at any version of the database whenever it was. That makes that all very effective. And specifically thinking about malware protection, right, we have the ability to set this up. So you've got policy-driven snaps happening every 10 minutes. They're safe. They can't be deleted. That's great. We can help you with alerting so you can be watching for, changes in the consume space and the snap deltas. We can show you, where the pieces are and be watching for that and help you say, hey, this storage group is doing something much different, right? Yesterday it had data reduction at, 4 to 1. Today it's the new stuff's coming in written is 1 to 1, right? Somebody has changed something dramatically. Look at this storage group now, right? So we're working on things to make that even more prevalent. So we're actually looking at very short-term shifts in data reduction within the storage group and being able to automate alerts on that, say something has dramatically changed even in the last few minutes in how the data happens here, pay attention. And that's useful for recovery. It's useful for detection because it's all right there in the box and done. The snaps are all protected so the bad guys can't delete them. And having this sort of process and procedure can also be useful when you're applying for things like cyber insurance, because cyber insurance is getting harder and harder to come by at any price. So showing that you're prepared to handle this kind of an invasion and rapidly recover your data can help the vendors who are offering you insurance to price it more effectively or be willing to offer it to you at all. And then you can also add SRDF, right? Once you got all this going on in the array, John talked about active, and DR copies, right? We can do all that as well, and you can run snaps on those as well. And you've got lots of great protection from this. So we think that PowerMax is one of the best platforms that you can use if you want your data well protected from this sort of malware. I will point out that we talk about this. So I'm doing snaps every 10 minutes for 2 days. That's 288 copies. So if you had a limit, some of our competitive arrays have a limit of 50,000 or 100,000 snaps in the box. If you have a limit of 100,000 snaps and you're doing 300 snaps per device, then you can really only have 350 host protected volumes. 350 LUNs isn't a lot for a production, large scale array. We can do it on 64,000 devices and still have, again, 1024 snaps each, millions of snaps. So, and I know that sounds like a big number, and who would do that? But we do have production customers doing it. I've got a large bank in the Midwest that's running 3 million plus snaps on each array, 5 arrays for their production boxes. And the same thing in each of the That's a 15 million snaps in each of their replicated environments and 3 copies with RDF. So it's a very real thing. It does add real customer value, and it's something that a lot of folks are really looking for. So RDF, we've got Sync, Async, and Metro. Again, RDF is the gold standard for how people do replication. John talked a little about Metro and the async copies. So the only thing I'm going to mention is further on the smart DR, right? You've got the A site, the B site, and the DR site, and you can be writing to either one. You can be reading and writing to A while you're reading and writing to B, right? And both will be sending updates to DR based on where you're doing writes. There is no latency difference, so it isn't like a LUN is owned by A or B. You write to A takes the write, sends it over to B, and you're done. Right? At the track level, whichever array gets written to owns that track until it's distributed to both, which is a synchronous distribution, and then you're done. So it's very different from a lot of the other architectures that try and say, well, A is primary, so if you write to B, I got to send it to A to send it back to B, or any of those kind of things. Right? This is all truly active, peer-based, and you won't see any response time difference whether you're running on A or running on B. And then you send that data to DR, and you wind up with a single target volume in the DR box. And if you fail A or you fail B, everything keeps running, including DR. And when you pull the other one back up, it all just reassembles itself and away you go. Right? It's all differential copies everywhere. So we've tried to make this really simple and easy. In fact, there's a GUI, you click, and you're done. You take a storage group on a primary array and said, add this one for Metro and add that for Smart DR, right? And it's 3 clicks in the GUI and you're done. So we've tried to make this really easy to build out for customers as well. Easy to set up, easy to manage, right? And speaking of management, we have the ability to do things in the GUI, obviously. Nice user interface, all using the HTML5, and everybody expects. You can manage things across the array and get all your dashboards and do all those things. We've got Cloud IQ to be able to manage it in the cloud, so you can look at a summary across multiple arrays, get all your key performance indicators, all that kind of stuff. We've got an extensive REST API, including a Python toolkit for that. So if you want to reach in with Python and do things, that's great. You want to step that up a level, you can decide, I want to use Ansible. So we have a full Ansible toolkit. So the Ansible toolkit is available on GitHub. It's all written in the Python toolkit that's available on GitHub. So if you say, hey, I like your Ansible toolkit, I like this playbook, but I want the play to happen a little differently in my environment, great, take the code, modify it. Now you've got your own version. You don't have to start it from scratch, right? We give you the full, here's the Ansible playbooks, right? Have a nice day. Make them out whatever you want. They're there for you to customize to make into what you need for your environment. We've got the container interface as well. We've got access to about however you want to do it. So, and then of course we still got the CLI because we've got some hardcore folks who've been around forever.